Artificial intelligence, or AI, has incredible potential to reshape almost every part of our lives, from healthcare and finance to transportation, cybersecurity, and even environmental protection. AI is already driving innovation and efficiency around the world. But while AI opens doors to economic growth and scientific progress, it also brings real risks. These risks can affect individuals, communities, organizations, and even the planet. Just like other technologies, AI risks vary. They can be short or long-term, high or low probability, and have either localized or widespread impacts. The NIST AI Risk Management Framework, or AI RMF version 1.0, defines an AI system as a machine-based system designed to achieve a specific goal by generating outputs such as predictions, recommendations, or decisions that can influence real or virtual environments. These systems can operate with different levels of autonomy, meaning some may act almost entirely on their own, while others still depend heavily on human oversight. Managing AI risk is more complex than managing traditional IT or software risks. That's because AI systems often learn from data that changes over time, which can unexpectedly alter how they behave or how trustworthy they are. They also exist within social and human contexts. People design, deploy, and interact with them. So AI risk isn't just technical, it's also social. The way people use AI, the data it relies on, and even the environment it operates in can all influence whether it does good or harm. Hi everyone, and welcome to the session on the NIST AI RMF. I'm Andrew Lash, and I'll be your guide as we explore how the NIST AI RMF helps organizations navigate these challenges, ensuring AI systems are transparent, accountable, and trustworthy, while still encouraging innovation and creativity. Let's begin by clarifying some foundational terms in artificial intelligence. Artificial intelligence, or AI, is essentially about designing machines that can perform tasks that normally require human intelligence, such as reasoning, learning, or making decisions. Generative AI, or Gen AI, refers to systems that can create new content like text, images, or even computer code. Think of it as a digital artist or writer trained on vast libraries of examples. Large language models, or LLMs, such as GPT, are specific types of AI trained on enormous amounts of text so they can understand and produce human-like language. Machine learning, or ML, is the foundation of most AI today. Rather than being explicitly programmed, ML models learn from data and improve their performance over time. Deep learning is a more advanced form of machine learning that uses layered neural networks, a bit like the way our brains process information, to handle complex data such as speech or images. Training data is the information we feed into these systems to help them learn patterns and make accurate predictions later on. When we apply a trained AI model to new situations or data, we call that process inference, essentially asking the system to make predictions based on what it has learned. Bias refers to systematic errors that lead to unfair or distorted outcomes, often caused by imbalanced or incomplete training data. For example, if a dataset mostly represents one demographic, the model's results may unintentionally favor that group. Explainability is about understanding how and why an AI system arrives at a certain outcome, a crucial aspect when decisions affect people's lives. Overfitting happens when an AI model becomes too familiar with its training data. It performs brilliantly on what it has seen but struggles when faced with new information, like a student who memorized practice questions but can't answer variations. Prompt engineering is the art of asking the right questions or giving the right cues to AI systems, especially language models, to achieve meaningful outputs. Reinforcement learning is like training a pet. The system learns through rewards and penalties for its actions, gradually improving its decision making. Finally, natural language processing, or NLP, enables machines to understand and communicate using human language, the foundation for chatbots, translation tools, and virtual assistants. AI isn't new. Its roots go back several decades, but recent breakthroughs in deep learning have brought AI to the forefront. These modern AI systems outperform earlier machine learning models like logistic regression, support vector machines, and random forests, especially in areas such as computer vision, language translation, and speech recognition. AI is a mix of different disciplines: computer science, math, engineering, and psychology, all working together to make machines that can think and learn like humans. Its main goal is to help systems do things that usually need human intelligence, such as learning from experience, solving problems, seeing or hearing patterns like images or voices, and making logical decisions. At the heart of AI are algorithms, step-by-step rules that learn from data. They can be as simple as a set of if this, then that instructions, or as advanced as a model that detects cyber threats or drives a car safely through traffic. AI isn't just one thing, it's a stack of layers, each one more specialized than the last. AI, the big umbrella, covers everything that helps machines mimic human thinking, from rule-based programs to self-learning systems. Machine learning, or ML, the data learner. ML helps machines learn from data instead of relying on human-coded rules. It looks for patterns in information and uses them to make predictions. As an analogy, imagine teaching a child to recognize animals. After seeing enough pictures of dogs and cats, they start spotting them on their own. That's machine learning in action. Deep learning, or DL, is the brain of AI. Deep learning uses neural networks, layers of algorithms that process information step by step, much like how our brain works. Each layer learns something new. The first might detect edges in a picture, the next spots shapes, and the final one recognizes a face. This is what powers technologies like facial. As an analogy, deep learning is like teaching an orchestra. Each musician or layer plays a part, but together they create a full symphony. Generative AI, or Gen AI, the creative mind. Gen AI doesn't just analyze data, it creates new things, such as text, music, code, art, or even video. It's like teaching the AI to be an artist or storyteller using what it has learned to make something entirely new. Special types of generative AI include the following: large language models, or LLMs. These are AI systems trained on massive amounts of text. They can understand and generate human-like language, which is why tools like ChatGPT can hold conversations so naturally. Generative Pre-trained Transformers, or GPT. GPT models are a specific kind of LLM that use a structure called a transformer. Transformers help AI understand the context of language, like knowing the difference between bank of a river and bank account. GPT-4. This is the fourth generation of the GPT family, and it's much better at understanding context, reasoning, and producing natural-sounding responses than its predecessors. Finally, ChatGPT is the application built on GPT technology, your digital conversation partner. It's designed to understand questions, remember context within a chat, and respond in a way that feels human and relatable. Without the right safeguards, AI systems can unintentionally reinforce or even worsen unfair or harmful outcomes for individuals and communities. That's why AI risk management is so important. It forms the foundation of responsible AI, ensuring that AI systems are designed, developed, and used in ways that align with ethical values and intended goals. Responsible AI focuses on three key ideas: being human-centered, socially responsible, and sustainable. By actively managing risk, organizations can encourage their teams, from designers and developers to deployers, to think critically about how AI will be used, who it will affect, and what both the expected and unexpected impacts might be. Understanding and managing AI risk isn't just about compliance, it's about building trustworthy systems that earn public confidence and make technology safer for everyone. This is where the NIST AI RMF comes in. It was created to help organizations identify and manage the unique risks that come with AI. Its goal isn't to slow innovation, it's to make sure that progress happens responsibly. In simple terms, the AI RMF helps us design AI that is powerful, fair, transparent, and aligned with human values. It gives organizations a clear, structured approach to ensuring their AI systems are accountable and trustworthy, while still allowing creativity and innovation to thrive. The NIST AI RMF is designed to help organizations build trustworthy and responsible AI systems. To make it easier to understand and apply the framework, it is divided into two main parts, each with a specific purpose. Part 1, the foundation, understanding AI risk and trustworthiness. Part 1 is like the blueprint of the framework. It helps organizations understand what AI risks look like and how to think about them. This part explains who the framework is for, its intended audience, and how to frame and analyze AI risks before jumping into technical fixes. It also introduces the 7 key characteristics of trustworthy AI, the qualities every responsible AI system should have. Part 2, the core and profiles, putting risk management into action. Part 2 is where the hands-on work happens. It's called the core because it lays out the practical steps for managing AI risks in real situations. It includes 4 key functions which serve as a structured roadmap for responsible AI. It includes govern, map, measure, and manage. These functions are divided into categories and subcategories, offering more detail on what organizations can do at each stage. Part 2 also includes profiles which help tailor the AI RMF to specific situations. For example, a particular industry like healthcare or finance, a specific AI use case like fraud detection, or a certain point of time like your current versus desired state. Profiles make the framework flexible, allowing organizations to adapt it to their unique goals, risk levels, and regulatory environments. Additional resources related to the framework are included in the AI RMF playbook, which is available via the NIST AI RMF website. I'll include a link to AI RMF resources in the description. AI risk management provides a structured way to reduce potential harms from AI systems, such as threats to civil liberties, privacy, and human rights, while also helping us maximize the positive outcomes that AI can bring. By actively identifying, documenting, and managing risks, organizations can make AI systems more trustworthy, transparent, and aligned with ethical and legal expectations. Within the NIST AI RMF, the term risk refers to a combination of 2 factors: likelihood, which is how probable it is that an event or issue will occur, and impact, which is how severe the consequences would be if it did. These 2 factors are common across most risk management frameworks and help organizations prioritize where to focus their attention. Framing risk is about understanding both the benefits and potential downsides of AI systems. Effective AI risk management is like quality control in manufacturing. It's there to catch problems before they reach the end user. By applying effective AI risk management throughout the entire system lifecycle, from design to deployment, organizations can prevent unintended consequences, protect people's rights, and build AI systems that earn and maintain public trust. Trustworthy AI systems and their responsible use can mitigate negative risks and contribute to benefits for people, organizations, and ecosystems. Some examples of potential harms related to AI systems are as follows. 1 is harm to people. AI systems can directly or indirectly cause harm to individuals and communities if not properly governed or tested. These harms can be physical, psychological, financial, or social, and may include the following: bias and discrimination. AI systems trained on unbalanced or biased data may produce unfair outcomes, such as denying loans, misidentifying people, or reinforcing harmful stereotypes. An example of this is a facial recognition system that performs poorly on certain demographic groups due to biased training data. Privacy violations. AI often relies on massive datasets that can include sensitive personal information. When data is misused or exposed, individuals' privacy, autonomy, and security can be compromised. Loss of autonomy and transparency. When AI decisions are opaque or black box models, individuals may lose the ability to understand or challenge automated outcomes, such as job screening or credit scoring results. Psychological harm and misinformation. Generative AI models can create convincing fake content, deepfakes, or misinformation, eroding public trust and causing emotional or reputational damage. In short, when AI systems fail to protect fairness, privacy, and transparency, they can directly harm the people they are intended to serve. 2. Harm to organizations. AI-related failures or misuse can also severely affect the organizations that design, deploy, or rely on these systems and may result in the following: reputational damage. An AI incident, like biased hiring algorithms or customer data misuse, can quickly become public, damaging brand trust and public perception. Legal and regulatory consequences. Non-compliance with data protection laws such as GDPR or New Zealand's Privacy Act, or emerging AI regulations can lead to lawsuits, fines, and loss of certification. Operational failures. Poorly designed AI systems can lead to bad business decisions, such as incorrect risk assessments, supply chain errors, or automated trading losses. Erosion of stakeholder trust. Investors, customers, and regulators expect transparency and accountability. Repeated AI missteps can reduce confidence in the organization's governance and integrity. Responsible AI risk management helps organizations avoid these harms by embedding transparency, accountability, and continuous oversight into every AI process. 3. Harm to ecosystems. Beyond individuals and organizations, AI can also have ripple effects on broader ecosystems, including society, the environment, and the digital landscape, which harms as follows. Societal harm. Widespread automation may disrupt labor markets, deepen inequality, or influence democratic processes through algorithmic bias or misinformation. Environmental harm. Large-scale AI training and data processing consumes significant energy and resources. If not managed sustainably, these activities contribute to carbon emissions and resource depletion. Ecosystemic dependence. As systems become more interconnected, one AI model's failure can cascade across sectors such as transport, health, or finance, amplifying systemic risk. Erosion of public trust in technology. Repeated misuse or harmful impacts of AI can lead to social resistance, reduced technology adoption, and long-term skepticism toward innovation. Managing ecosystem-level risks requires a systems-thinking approach, looking beyond one organization's boundaries to consider the collective long-term consequences of AI deployment. One of the biggest challenges in managing AI risks is that not all risks are clearly defined or fully understood. When something can't be defined clearly, it's difficult to measure, whether using numbers or quantitative methods, or expert judgment, also called qualitative methods. But it's important to remember that not being able to measure a risk precisely doesn't automatically mean the system is high risk or low risk. It simply means there's uncertainty, and that's something we need to manage thoughtfully. Let's explore some of the main challenges in measuring AI risk. 1. Risks involving third-party software, hardware, or data. Many AI systems rely on third-party tools, data, or infrastructure. These can speed up development, but also introduce new risks. For example, a company developing an AI model might use external training data or pre-built software that has its own biases or security flaws. Another challenge is misalignment of risk approaches. The organization creating the AI system might use one risk framework, while the organization deploying it uses another. If they are not aligned or transparent about their methods, the overall system risk becomes hard to assess or manage. Finally, customers who integrate third-party tools into their own AI systems without strong governance or technical safeguards may unknowingly increase their exposure to risk. No matter the role, developer, deployer, or user, every AI actor shares responsibility for managing risk in the systems they work with. 2. Tracking emerging risks. AI systems evolve. As they are updated or interact with new data, new risks can appear, sometimes unexpectedly. That's why responsible organizations continually monitor and track emergent risks, updating their measurement methods as the technology and its context change. 3. Lack of reliable metrics. Right now, there's no universal agreement on how to manage AI risk or trustworthiness. Each organization and even each use case might apply different metrics or standards. This lack of consistency makes it difficult to compare systems or verify that one model is truly safer or more trustworthy than another. 4. Risk across the AI lifecycle. AI risk is not static. It changes as a system moves from design to deployment and beyond. A risk identified early in development might look very different once the AI system is deployed in the real world. Some risks are latent, meaning they don't show up until later, for example, after exposure to new data or environments. Different AI actors also view risk differently. A developer who creates a pre-trained model might see one set of risks, while the organization that deploys that model in a specific application might face very different ones. That's why collaboration across the lifecycle is essential. Everyone involved shares responsibility for ensuring AI remains fit for purpose and is trustworthy. 5. Risks in real-world settings. Testing AI systems in a lab or controlled environment can help identify risks early, but those conditions rarely match real-world complexity. Once deployed, AI systems encounter unpredictable inputs, users, and environments that can reveal new or amplified risks. That's why post-deployment monitoring is a critical part of AI risk management. 6. Inscrutability or opacity or lack of transparency. Many AI systems, especially those built using deep learning, are difficult to fully explain or interpret. This black box nature can make it challenging to understand why a model made a certain decision, which complicates measuring and managing risk. Lack of documentation or transparency during development can make the problem even worse. 7. Establishing a human baseline. When AI is used to replace or assist human decision making, it's useful to compare its performance against a human baseline, but that's not easy. Humans and AI systems perform tasks differently under different conditions and with different limitations. Because of this, defining what good performance or acceptable risk means can vary widely depending on the context and the task. The AI RMF can help organizations prioritize which risks to focus on, but it doesn't tell them how much risk they should be willing to accept. That's where the concept of risk tolerance comes in. Risk tolerance is the level of risk an organization or an AI actor is willing to accept in pursuit of its goals. Think of it like setting a speed limit for your AI program. Some organizations are comfortable driving fast to innovate quickly, while others prefer a slower, more cautious approach to stay well within safety limits. An organization's risk tolerance isn't arbitrary. It's influenced by laws, regulations, industry standards, and social expectations. For example, a healthcare provider developing diagnostic AI will likely have a much lower risk tolerance than a marketing company experimenting with ad personalization because the potential impact on human life is far greater. Risk tolerance also depends heavily on context and use case. What's considered an acceptable level of risk in one domain might be acceptable in another. Over time, as AI systems, policies, and social norms evolve, an organization's risk tolerance will evolve too, just as safety standards in industries like aviation and medicine have changed with technology advancements. In short, risk tolerance is about balance, finding the right point between innovation and protection, ambition and responsibility. It helps organizations align their decisions about AI with both their objectives and their ethical values. When applying the AI risk management framework, not all risks are created equal. Some risks pose a much greater threat than others, and those need to be prioritized. In simple terms, risk prioritization means focusing your attention and resources on the risks that could cause the most harm or have the greatest impact within the specific context of how your AI system is used. Think of it like triage in an emergency room. Doctors treat the most critical patients first. Similarly, when managing AI risks, organizations should first address the highest risks, those that could result in serious harm to people, organizations, or the environment. If an AI system presents unacceptable risk levels, for example, when severe harms are already occurring, catastrophic impacts are likely, or the risks simply cannot be controlled, then development and deployment should stop immediately. The system should only proceed once those risks have been properly mitigated or managed in a safe and responsible way. Risk prioritization will look different depending on the type of AI system and its level of human interaction. AI systems that interact directly with people, such as those used in healthcare, education, hiring, or justice, usually require higher initial prioritization. This is especially true when they use large datasets containing sensitive or protected information like personal data or biometrics. AI systems that do not directly interact with people and that use less sensitive data, for example, environmental sensors or internal computational models, might initially be assigned a lower risk priority. However, even non-human facing systems can still have downstream effects. For instance, a model managing energy usage might indirectly affect public safety or the environment. That's why risk prioritization must be ongoing. It should be regularly reviewed and adjusted as systems evolve, context change, and new risks emerge. The OECD, or Organization for Economic Cooperation and Development, developed a framework to help classify AI activities across the AI lifecycle. This framework looks at AI through 5 key socio-technical dimensions, meaning it considers both technical design and the human or social impact of AI. These dimensions are critical for policy making, governance, and risk management. NIST adopted and slightly modified this framework for its AI RMF. In NIST's version, there's an extra emphasis on testing, evaluation, verification, and validation, also called TEVV, which ensures AI systems are reliable, safe, and function as intended throughout their lifecycle. Let's break down the main dimensions shown in the framework diagram. The application context, environment and purpose for which AI is being used. Data and input, the information the AI system learns from or uses to make decisions. AI model, the algorithms and processes that power the system. Task and output, the results the AI generates, such as predictions, recommendations, or actions. And people and planet, shown at the center of the figure, representing human rights, social well-being, and environmental sustainability. AI actors involved in these dimensions who perform or manage the design, development, deployment, evaluation, and use of AI systems and drive AI risk management efforts are the primary AI RMF audience. The two inner circles show AI systems key dimensions, and the outer circle shows AI lifecycle stages. Ideally, risk management efforts start with the plan and design function in the application context and are performed throughout the AI system lifecycle. Managing AI risk isn't something that a single person, team, or organization can do alone. It's more like a group project. Success depends on everyone working together and sharing responsibility. The AI ecosystem is made up of many different AI actors, each playing an important role. Designers and developers build and code the system. Data scientists train models and analyze patterns. Policymakers and regulators set the rules and ensure accountability. Users and end users interact with AI in the real world and provide feedback. Each of these roles brings unique expertise and perspectives that help spot risks others might miss. As an analogy, think of AI risk management like building a bridge. Engineers design it, safety inspectors test it, local authorities approve it, and the public uses it. If any one of those groups works in isolation, the bridge might look strong but could still fail under pressure. Collaboration keeps it safe and reliable. The NIST AI RMF encourages bringing together people from different disciplines such as technical experts, ethicists, social scientists, and even everyday users. When these diverse minds collaborate, they challenge assumptions that might otherwise go unnoticed. They spot blind spots or risks that technical teams alone might overlook, and they identify emerging problems early before they become major issues. Think of it like assembling a superhero team. Each person has a different power. One sees data bias, another spots ethical issues, another ensures compliance. Together they protect the AI system and society from potential harm. AI risk management succeeds when it's shared. By combining perspectives from developers to decision makers, we create AI systems that are safer, fairer, and more trustworthy for everyone. Building trustworthy AI means creating systems that people, organizations, and societies can depend on. When AI is designed responsibly, it can reduce negative risks and deliver benefits safely and ethically. According to NIST, trustworthy AI systems share several key characteristics. Think of these as the pillars of trust. Each one supports the stability and reliability of the overall system. Let's discuss these characteristics now. 1. Valid and reliable. To trust an AI system, we first need to know it works as intended, not just in the lab, but also in real-world conditions. Validity means the AI system achieves its purpose correctly. For example, if a medical AI tool is designed to detect tumors, it must reliably detect them in different hospitals and under different lighting conditions. Reliability means the system performs consistently over time without failing. Validation and reliability come from ongoing testing and monitoring, much like how car manufacturers continually test vehicles for performance and safety even after they are on the market. If AI systems are inaccurate or unstable, trust breaks down quickly, especially when decisions impact people's health, safety, or rights. 2. Safe. AI systems should never put people, property, or the environment in danger. Safety in AI is achieved by designing and testing responsibly, providing clear guidance for safe use, and documenting risks and previous incidents so lessons can be learned. Systems that could cause serious harm, like those in healthcare, transportation, or defense, require the highest level of scrutiny before deployment. As an analogy, just like a new airplane must pass multiple flight safety tests before carrying passengers, AI systems need rigorous checks before being trusted in real-world use. 3. Secure and resilient. A secure AI system can protect itself from attacks, data theft, and manipulation. A resilient AI system can recover gracefully if something unexpected happens. These qualities protect the system's confidentiality, integrity, and availability, the same principles used in cybersecurity. Examples of threats include adversarial attacks, data poisoning, or model theft. As an analogy, security is like locking your doors to prevent intruders. Resilience is having an emergency plan, knowing how to rebuild and keep going if something still goes wrong. 4. Accountable and transparent. Trustworthy AI depends on accountability, knowing who is responsible for the outcomes. Accountability is built on transparency, meaning people should understand when AI is being used and how it influences decisions. Transparency helps users challenge or correct errors and builds confidence in the system. Maintaining records of how data is collected and used also supports both accountability and compliance with copyright or privacy laws. As an analogy, transparency in AI is like the ingredient label on food. It helps consumers understand what's inside, make informed choices, and hold producers accountable for safety or accuracy. 5. Explainable and interpretable. AI should be able to explain what it does, how it works, and why it makes certain decisions, at least to the people responsible for it. Explainability describes how a system makes decisions, or the process. Interpretability describes why it made a particular decision and what that means in context. For example, in a credit approval system, explainability tells us which data points influenced the decision, while interpretability helps us understand why a person was approved or denied. Transparency answers what happened, explainability answers how it happened, and interpretability answers why it happened. As an analogy, think of AI like a GPS. Transparency tells you the route it took, explainability shows how it calculated it, and interpretability explains why that route was chosen, maybe it avoided traffic or roadworks. 6. Privacy enhanced. Privacy is about protecting people's autonomy, dignity, and control over their personal information. AI systems should minimize unnecessary data collection and use techniques like anonymization or aggregation to protect individuals. Privacy-enhancing technologies, or PETs, like differential privacy or secure multi-party computation, can help ensure that sensitive information is not exposed. As an analogy, think of PETs as tinted windows. They let the system see through enough to operate safely, but prevent outsiders from seeing personal details. 7. Fair, with harmful bias managed. Fairness in AI means treating people and groups equitably and minimizing harmful bias. Bias in AI can appear in 3 main ways. Firstly, systemic bias, from social or organizational patterns that shape data and design choices. Secondly, computational bias, from algorithms trained on non-representative or unbalanced data. And thirdly, human cognitive bias, from the assumptions or perceptions of the people designing or using AI systems. While some level of bias is natural, even in human decisions, AI can amplify bias at scale, spreading harm more quickly. Managing bias is essential for fairness and trust. As an analogy, imagine training a facial recognition system with photos mostly of one demographic. It's like teaching a child to recognize only one type of face. The child might do well in that small group but fail to recognize others fairly. Part 2. The AI RMF core is the heart of the NIST AI RMF. It provides a practical structure, a set of outcomes and actions that organizations can use to understand, discuss, and manage AI risks while developing trustworthy and responsible AI systems. The core is made up of 4 main functions. Govern, establishing the culture, policies, and accountability structures for AI. Map, understanding and framing the AI system, its purpose, and potential impacts. Measure, assessing, testing, and quantifying AI risks and system performance. And finally, manage, acting on the results to reduce, monitor, and respond to risk over time. Each of these high-level functions is further divided into categories and subcategories that describe specific goals and outcomes. However, these are not meant to be a checklist or a strict sequence of steps. Instead, they offer a flexible structure that organizations can tailor to their size, resources, and context. Importantly, governance, or govern function, plays a central role. It's a cross-cutting function, meaning it influences and supports every other part of the framework. Good governance sets the tone for ethical behavior, accountability, and transparency across the AI lifecycle. To make implementation easier, NIST provides an online companion called the AI RMF Playbook. This resource gives organizations practical examples and tactical actions they can adopt based on their unique situations. Organizations can use the AI RMF in different ways. Some may focus on one or two functions first, while others may adopt the entire structure from the start. Typically, after governance practices are in place, teams begin with the map function, move on to measure, and then manage their AI risks. However, this process is iterative, meaning it's revisited and refined over time. The functions are interconnected, so insights gained from one area often inform the others. As an analogy for learners, think of the AI RMF core like building and maintaining a safe city. The govern function sets the city's laws, ethics, and oversight, which is the foundation for everything else. The map function creates the city's blueprint, understanding where the roads, services, and boundaries are. The measure function inspects and monitors, includes testing the roads, bridges, and safety systems to ensure they work properly. And finally, the manage function keeps the city running, so repairing, improving, and responding to any new risks that arise. Just as a city never stops evolving, AI risk management is an ongoing adaptive process that grows as technology, data, and social expectations change. The govern function is the foundation of the NIST AI RMF. It focuses on building the organizational culture, structures, and processes needed to manage AI responsibly. In simple terms, govern is about setting the rules of the game, ensuring that everyone involved in the design, development, and use of AI systems understands their responsibilities and acts in alignment with ethical and legal standards. The purpose of the govern function is to make sure AI risk management is not an afterthought. It's embedded into the organization's DNA from the very beginning. This includes the following: establishing clear accountability and oversight by defining who owns which parts of AI risk management, creating and maintaining policies, procedures, and codes of conduct that guide responsible AI use, encouraging transparency, documentation, and communication so decisions are explainable and auditable, building a risk-aware culture where teams think critically about fairness, safety, and security at every stage of AI development, ensuring alignment with organizational values and regulatory expectations, especially as global standards like ISO, the EU AI Act, and others continue to evolve. The govern function also encourages organizations to involve diverse stakeholders, technical experts, ethicists, legal advisors, and end users, because inclusive governance helps prevent blind spots and ensures AI systems serve everyone fairly. In AI terms, govern ensures that innovation happens safely, responsibly, and with purpose, guiding every decision that follows in the map, measure, and manage functions. Next, we'll look at the categories and subcategories that make up the govern function. The table shown on the screen is broken down into the following columns. So we have the category ID, the category title, the subcategory ID, and the subcategory text. The first category ID item is govern 1. Policies, processes, procedures, and practices across the organization related to the mapping, measuring, and managing of AI risks are in place, transparent, and implemented effectively. This category includes 7 subcategories, labeled from 1.1 to 1.7. Govern 2. Accountability structures are in place so that the appropriate teams and individuals are empowered, responsible, and trained for mapping, measuring, and managing AI risks. This category includes 3 subcategories with IDs 2.1 to 2.3. Govern 3. Workforce diversity, equity, inclusion, and accessibility processes are prioritized in the mapping, measuring, and managing of AI risks throughout the lifecycle. This category includes 2 subcategories, 3.1 to 3.2. Govern 4. Organizational teams are committed to a culture that considers and communicates AI risk. This includes 3 subcategories. Govern 5. Processes are in place for robust engagement with relevant AI actors. This category has 2 subcategories. Govern 6. Policies and procedures are in place to address AI risks and benefits arising from third-party software and data and other supply chain issues. This has 2 subcategories. I recommend that you have a further look at these categories and subcategories within the AI RMF, and the NIST AI RMF playbook includes further information on how to implement these subcategories. The map function helps organizations understand and frame the risks associated with an AI system before it's built, deployed, or scaled. Think of it as the discovery and exploration phase, where you ask the right questions to truly understand what you're creating, why you're creating it, and who it might impact. The goal of the map function is to ensure that AI systems are developed with context in mind, not just from a technical perspective, but also from ethical, social, and environmental viewpoints. This includes defining the intended purpose and scope of the AI system, what it is supposed to do, and what decisions will it influence. Identifying who might be affected, including individuals, communities, organizations, or even ecosystems. Considering potential benefits and harms, including unintended consequences or misuse. Understanding dependencies such as data sources, hardware, third-party tools, and integrations that could introduce risks. Evaluating legal, ethical, and societal implications by ensuring compliance with privacy laws, non-discrimination standards, and other relevant frameworks. Assessing contextual factors such as the operating environment, level of autonomy, and how humans interact with or oversee the system. By mapping out the system and its environment early, organizations can detect blind spots like data biases, hidden assumptions, or overlapping responsibilities that could lead to issues later. An analogy for learners: imagine you're planning a road trip across a new country. Before you start driving, you check your destination and route, which is the purpose and scope. Look at the terrain and road conditions, which is the context and dependencies. Identify potential hazards like bad weather or rough roads, which are the risks and harms. And make sure you understand local laws and customs, which are the regulations and ethics. That's exactly what the map function does for AI systems. It ensures you're not driving blind into unknown territory. It helps you see the full landscape of risks, stakeholders, and impacts before you even start the engine. A good map process combines technical assessments like data quality or model limitations with human-centered insights like how people might interpret or misuse the system. It's a stage where teams can pause and ask, do we truly understand what this AI system is doing? Are we solving the right problem? Could we create harm, even unintentionally? By taking time to map the AI system properly, organizations set themselves up for success in the next stages, which are measure, quantifying the risks, and manage, taking action. Next, we'll take a look at the categories and subcategories that make up the map function. Category ID 1, map 1. Context is established and understood. There are 6 subcategories that are included within this first category ID. Map 2, categorization of the AI system is performed, which includes 3 subcategories. Map 3, AI capabilities, targeted usage, goals, and expected benefits and costs compared with appropriate benchmarks are understood. This includes 5 subcategories. Map 4, risks and benefits are mapped for all components of the AI system, including third-party software and data. Includes 2 subcategories. And Map 5, impacts to individuals, groups, communities, organizations, and society are characterized. Includes 2 subcategories. Once again, I recommend that you utilize the NIST AI RMF playbook for further information on the implementation of these categories and subcategories. The measure function is all about checking how well an AI system performs and how trustworthy it really is. Think of it as the health check for your AI, testing how it behaves before it's launched and monitoring it regularly once it's in action. To do this, organizations use a mix of quantitative tools like statistics and performance scores, and qualitative tools like human judgment, observations, and feedback. In many cases, the best results come from combining both approaches, using hard data to measure what you can, and expert insight to understand what numbers alone can't explain. When you measure AI risks, you're essentially asking questions like, is this AI system working as intended? Can we trust its outputs? How does it behave in real-world conditions? This involves the following: testing the system before deployment, just like you'd test a car before driving it off the lot. Monitoring performance regularly once it's in operation to catch issues early. Tracking metrics related to key characteristics such as fairness, safety, privacy, accuracy, reliability, and explainability. Documenting results clearly by creating a record of how the system performs and how decisions about improvements were made. These results are used later in the manage function, where organizations decide how to respond to any risks or trade-offs that arise. The measure function helps make decisions regarding AI use visible and evidence-based so that decisions can be made consciously rather than by accident. It provides a traceable record that explains why certain actions, like adjusting, retraining, or even retiring a model, were taken. Think of it like a car service analogy. Imagine your AI system as a car. Before you drive it, you check the engine, brakes, and tires. Once it's on the road, you still bring it in for regular servicing to make sure that it's running safely and efficiently. If something feels off, say strange noises or reduced fuel efficiency, you measure and diagnose what's wrong and then decide how to fix it. That's exactly what the measure function does for AI systems. It continuously checks for engine health across all the factors that make AI trustworthy and reliable. Measurement doesn't stop once an AI system is live. Because AI evolves as data changes, environments shift, or user behavior adapts, measurements must also evolve. Organizations need to keep their metrics and testing methods up to date, track new kinds of risks as they appear, and keep refining their measurement tools as AI systems and standards mature. By continuously measuring, documenting, and refining, organizations build a solid foundation of trust that supports the responsible use of AI now and into the future. Next, we'll look at the categories and subcategories that make up the measure function. Category ID Measure 1. Appropriate methods and metrics are identified and applied. This includes 3 subcategories. Measure 2. AI systems are evaluated for trustworthy characteristics. This includes 13 subcategories. Measure 3. Mechanisms for tracking identified AI risks over time are in place. Includes 3 subcategories. Measure 4. Feedback about efficacy of measurement is gathered and assessed. Includes 3 subcategories. The manage function is where everything comes together. Once we've identified risks through map and measured their impacts through measure, the manage function focuses on what to do about them. This means putting in place the right plans, controls, and actions to reduce risks, respond to incidents, and continuously improve the AI system over time. The manage function involves allocating resources to the risks that matter most on what was defined earlier in the govern function, developing response plans by deciding how to react if things go wrong or if new risks appear, preparing recovery strategies so the organization can bounce back quickly from incidents, and communicating clearly by ensuring all relevant stakeholders and AI actors understand what's happening and what to do next. In other words, the manage function is about turning insight into action. It uses what was learned from earlier stages to keep AI systems reliable, safe, and aligned with organizational goals. An analogy to be used is to think of the manage function like piloting an aircraft. You've already built the plane, that's the government and map stages, and you've tested all the instruments, which is the measure. Now, while flying, you're constantly managing conditions, adjusting the control, responding to turbulence, and checking gauges to make sure everything stays on course. Even when things go smoothly, you're still alert, monitoring for changes in weather and performance. And if an issue does arise, say engine trouble, you already have a response and recovery plan in place to guide you safely back to control. That's what the manage function does for AI systems. It keeps the flight steady and ensures any problems are addressed quickly and effectively. Once the manage function is in place, organizations aren't done. They've just entered a cycle of ongoing improvement. Regular monitoring, review, and updates help ensure that risks are continually re-evaluated, lessons learned from incidents are applied, and the AI system becomes more resilient and trustworthy over time. By completing this stage, organizations have a clear, repeatable process for prioritizing, monitoring, and improving AI risk management, turning principles into sustained, responsible action. Next, we'll look at the categories and subcategories that make up the manage function. Category ID Manage 1. AI risks based on assessments and other analytical output from the map and measure functions are prioritized, responded to, and managed. This includes 4 subcategories. Manage 2. Strategies to maximize AI benefits and minimize negative impacts are planned, prepared, implemented, documented, and informed by input from relevant AI actors. This includes 4 subcategories. Manage 3. AI risks and benefits from third-party entities are managed, includes 2 subcategories. And Manage 4. Risk treatments, including response and recovery, and communication plans for the identified and measured AI risks are documented and monitored regularly. This includes 3 subcategories. When it comes to managing AI risk, one size definitely doesn't fit all. Different organizations, sectors, and use cases face very different challenges, and that's where AI RMF profiles come in. Think of profiles as customized maps that show how an organization can apply the AI risk management framework to their specific situation. They help translate the framework's high-level principles into practical actions that fit your goals, industry, and resources. AI RMF profiles help organizations do the following: align their risk management practices with their business objectives, incorporate legal, regulatory, and ethical requirements, follow best practices that reflect their risk tolerance and resources. Essentially, they act as a blueprint for how to manage AI risk effectively in your particular context, whether you're developing healthcare AI, financial models, or government systems. The NIST AI RMF defines several types of profiles, each serving a specific purpose. 1. Use case profiles. These are tailored for specific applications or environments. They show how the AI RMS functions, govern, map, measure, and manage, can be applied in a real-world setting based on your organization's goals and resources. For example, a hospital might create a use case profile for an AI diagnostic tool showing how it handles patient data, ensures fairness, and manages model drift. 2. Temporal profiles. Temporal profiles focus on time and progress, showing where you are now and where you want to be. A current profile describes how AI risk has been managed today, including your present strengths and weaknesses. A target profile represents your desired future state, how you want AI risk to be managed. By comparing the two, you can identify gaps and build an action plan to close them. As an analogy, think of it like a before and after fitness plan for your AI program. The current profile shows your baseline, while the target profile represents your ideal level of maturity. 3. Cross-sectoral profiles. These profiles look at risks that span multiple industries or applications. They're especially helpful for technologies that cut across sectors, like large language models, cloud AI services, or data sharing platforms. For example, a cross-sectoral profile could address how to safely use generative AI across education, healthcare, and finance, where privacy, fairness, and reliability all matter, but in slightly different ways. Profiles are powerful because they help organizations see where they stand, where they want to go, and how to get there. By using AI RMF profiles, whether use case, temporal, or cross-sectoral, organizations can create a structured, goal-oriented roadmap for trustworthy AI development and deployment. Profiles make the AI RMF personal. They turn abstract framework principles into actionable real-world steps, tailored to your mission, your risks, and your pace of change. To understand how AI systems are responsibly built and maintained, it's helpful to look at the different roles or actors involved throughout the AI lifecycle. Think of this lifecycle like building and maintaining a city. You need planners, builders, inspectors, and maintenance teams all working together to keep things running smoothly. Each group of AI actors has its own responsibilities, and they collaborate at different stages to make sure the system is safe, lawful, and trustworthy. We'll now work through each of the different AI actors. AI design actors are the architects and planners. Design stage is where everything begins. These actors create the concept of the AI system, defining what it should do, how it should behave, and why it's been built. AI development actors are the builders and engineers. Once the plans are approved, the development actors take over. They build and test the core model or algorithm that powers the AI system. AI deployment actors are the project managers and integrators. Deployment actors handle everything involved in launching the AI system into production, ensuring it's ready to operate in the real world. AI operation and monitoring actors. the maintenance and safety teams. Once the system is up and running, operation and monitoring actors ensure everything continues to function as intended. TEV actors. Human factors, the designers who keep people at the center. Human factors tasks are all about making AI systems work for people, not the other way around. These activities include designing interfaces that are intuitive, ensuring users can understand and trust the AI, and adapting systems to fit real human behaviors and cultural context. Domain experts, the subject matter guides. Domain experts bring deep knowledge of the field where the AI will be used, such as healthcare, law, transport, or finance. Their expertise ensures the AI system truly understands the environment it operates in and meets the specific needs of that sector. AI impact assessment, the auditors of trust and accountability. Impact assessors focus on the ethical and societal consequences of AI systems. Their work goes beyond the technical. It's about understanding how AI affects people, communities, and organizations. Procurement, the gatekeepers of trusted AI solutions. Procurement actors are the ones responsible for buying or contracting AI products or services from external vendors. They make sure that the systems being acquired meet the organization's technical, ethical, and legal requirements. Governance and oversight, the leaders and guardians. Governance and oversight roles belong to those at the highest levels of organizational responsibility, such as senior management, legal counsel, and boards of directors. These leaders are accountable for the overall direction, integrity, and sustainability of AI use within their organizations. Third-party entities, the external contractors. These are external organizations or vendors who design, develop, or provide parts of an AI system, such as data, algorithms, models, or even platforms. They are responsible for certain design and development tasks, but they don't belong to the internal team of the company that uses the AI system. End users, the people who actually use the AI. End users are the individuals or groups who directly interact with the AI system to achieve a specific goal. They could be AI experts who understand how the system works, or first-time users who just want it to do the job. Their experience and feedback are vital for ensuring the system is usable, trustworthy, and effective in the real world. Affected individuals and communities, the people impacted by AI. Not everyone influenced by an AI system actually uses it. Affected individuals or communities include people or groups who are indirectly impacted by AI decisions. For example, communities affected by automated hiring tools, credit scoring systems, or surveillance technologies. Even though they don't interact with the system, the consequences of its outputs can shape their opportunities, rights, or well-being. Other AI actors, for example, standard setters, advocacy groups, etc. These actors create or promote guidelines, best practices, and standards for responsible AI. They include standards organizations, professional or trade associations, advocacy and civil society groups, researchers, and environmental groups. They help define what good AI looks like, ensuring fairness, transparency, and accountability in how AI systems are built and used. The general public, the ultimate audience. Finally, there's the general public, the people who experience the real-world benefits and risks of AI technologies. This includes individuals, consumers, and communities across society. Their trust, or lack of it, can strongly influence how AI is adopted, regulated, and improved. Public opinion often shapes policy decisions and encourages ethical action from AI developers and organizations. Each AI actor plays a crucial role in ensuring the system remains trustworthy, accountable, and safe. When these roles work together effectively, from architects to inspectors, organizations can build AI systems that are not only powerful and innovative, but also responsible and resilient. AI success isn't just about the technology, it's about teamwork across the entire life cycle. The NIST AI RMF playbook is like a user's manual for the AI RMF. It was created through collaboration between the public and private sectors, meaning government experts, industry leaders, and researchers all had a hand in shaping it. While the main AI RMF explains what organizations should do to manage the AI risks, the playbook shows how to actually do it. The playbook helps organizations navigate and apply the AI RMF in real-world settings. It gives practical guidance for embedding trustworthiness into every stage of an AI system's lifecycle, from design and development all the way through deployment and daily use. The playbook is based on AI RMF version 1, released in 2023, and it provides suggested actions to help you meet the goals of the framework, references and guidance from research and best practices, practical examples tied to the four main AI RMF functions being govern, map, measure and manage. The playbook is voluntary. You can use as much or as little of it as fits your organization, whether you're a startup building your first AI tool or a large enterprise managing multiple systems. You can pick and choose the sections that best apply to your goals, risks and industry. AI is advancing at lightning speed, but with great power comes great responsibility. As AI spreads across industries and borders, governments around the world are stepping up to set the rules of the game, aiming to protect people, build trust and ensure AI works for society, not against it. Imagine if cars were invented but no one set traffic rules. Chaos would follow. AI is similar. It's powerful, but without clear guardrails, it can cause real harm, from biased hiring systems to privacy-invading surveillance. That's why countries around the globe are introducing laws and frameworks to manage AI risks, ensure transparency and accountability, protect human rights, and encourage ethical innovation. Governments are essentially becoming traffic controllers for AI, setting signals to guide safe and responsible use. The Modulus webpage offers a curated overview of key AI regulations shaping the global compliance landscape. While it doesn't cover every single regulation out there, it's designed to highlight the most impactful laws and provide actionable insights for businesses. High-profile incidents have underscored the urgent need for governance, from algorithms that unintentionally discriminate in hiring to AI-driven surveillance systems that threaten privacy. These examples have sparked global conversations about the responsible use of AI. Trust is the cornerstone of technology adoption, and without accountability, AI's promise can quickly turn into public distrust. For organizations, the global AI landscape feels like a maze of overlapping rules. Each country or region has its own framework, some stricter, some more flexible, but all share one goal: to make AI trustworthy. As AI becomes part of everything from healthcare to hiring, governments around the world are stepping up to make sure it's used responsibly and safely. Think of it this way: if AI is like a fast-moving train of innovation, regulations are the tracks and signals that keep it running in the right direction and prevent collisions along the way. The following list highlights some of the most influential AI laws and frameworks shaping how the world manages AI risks. The EU AI Act is the world's first comprehensive legal framework for AI, following a risk-based approach to ensure safety, transparency and accountability. Like GDPR did for data privacy, the EU AI Act is expected to shape global AI compliance standards. Key elements of the EU AI Act are as follows. It uses a risk-based classification. AI systems are categorized into 4 levels: unacceptable risk, which is banned AI; high risk, which are strictly regulated; limited risk, with transparency obligations; and minimal risk, with no specific requirements. Compliance requirements. High-risk AI systems must adhere to strict obligations including risk management, transparency, human oversight, and data governance. Penalties. Non-compliance can result in fines of up to €35 million or 7% of global turnover, whichever is higher. The Act officially entered into force in August 2024 with phased implementation through 2027. Businesses operating in or interacting with the EU market must assess their AI systems and ensure compliance. Council of Europe Framework Convention on AI and Human Rights. This was signed in September of 2024 in Vilnius. This convention establishes a comprehensive legal framework designed to ensure that all activities within the AI lifecycle adhere to fundamental human rights, democratic principles, and the rule of law. It applies to public authorities and private actors acting on their behalf, mandating that states implement graduated, context-specific measures to manage AI-related risks, ranging from potential discrimination and privacy breaches to threats against democratic processes. The next regulation is Brazil's proposed AI bill, or PL 2338-2023. The bill is built on 4 key pillars: risk-based governance, human rights protection, transparency and innovation. Its objective is to ensure that AI systems align with democratic values, safeguard user rights, and promote responsible technological advancements in Brazil. The next regulation is South Korea's Basic Act on AI Advancement and Trust. Passed in November 2024, this establishes a regulatory framework to foster responsible AI development while safeguarding public trust. This legislation represents a significant step in positioning South Korea as a leader in both technological innovation and ethical AI governance. The law aims to promote safety, transparency, and fairness across all AI applications, with particular emphasis on high-impact systems and generative AI. Scheduled to take effect in late 2025, it introduces obligations for both domestic and foreign entities offering AI products and services within South Korea. The next regulation is California's Generative AI Training Data Transparency Act, or AB 2013. This sets a precedent as the first law in the United States to mandate disclosure of training data for generative AI systems. Signed into law on September 28, 2024, it aims to promote transparency in AI development, safeguard personal information, and empower users with a greater understanding of how AI outputs are created. This groundbreaking legislation will take effect on January 1, 2026, applying retroactively to AI systems made available to Californians since January 1, 2022. By enforcing public disclosure of training datasets, California seeks to establish trust in generative AI systems while holding developers accountable for their choices in data sourcing and processing. The next regulation is the Colorado Senate Bill 24-205, Consumer Protections for AI. This is a landmark regulation aimed at protecting residents from algorithmic discrimination in high-risk AI systems. Signed into law and set to take effect on February 1st, 2026, the bill requires developers and deployers of AI systems to prioritize transparency, risk management, and consumer rights. By addressing AI's impact in critical areas such as employment, housing, and finance, the law ensures that AI systems are used ethically and without bias in decisions that significantly affect individuals' lives. The next regulation is the U.S. Artificial Intelligence Research, Innovation and Accountability Act, S.3312. This seeks to establish a federal regulatory framework for AI systems in the United States. This proposed legislation introduces new compliance requirements for generative AI, high-impact systems, and critical impact systems to enhance transparency, accountability, and risk management. Although not yet enacted, it signals a growing push for structured AI governance across industries. The bill aims to strike a balance between fostering innovation and ensuring AI systems operate responsibly, particularly in applications that directly impact individuals' rights, safety, or public trust. The NIST AI RMF is covered in this training lesson, and the final one we'll be looking at is the Texas Responsible AI Governance Act, or TRAIGA. This is a forward-looking regulatory framework designed to govern the development, deployment, and use of AI systems in Texas. With an effective date of September 1, 2025, this legislation introduces strict requirements for high-risk AI systems, focusing on transparency, risk management, and consumer protection while fostering innovation through a regulatory sandbox. TRAIGA reflects Texas's commitment to balancing responsible AI governance with business-friendly policies, ensuring organizations can innovate while protecting users from potential risks. I'll provide a link to the Modulus website, which goes into these regulations in a bit more detail than I have provided in this particular presentation. I encourage you to have a look at that. It's got some very good information, and the table that you can see on the screen has a summary of some of the regulations across the top row, and the first column includes information around the scope, risk classification, penalties, transparency requirements, effective date, enforcement authority, small business exemption, regulatory sandbox, and human oversight requirements for each of these regulations. So it gives a nice little summary for each of these regulations. Let's wrap up what the NIST AI RMF helps organizations achieve in simple terms. 1. Balances innovation with safety. AI is like a high-powered engine, exciting but potentially dangerous without good brakes. The AI RMF helps teams innovate confidently while keeping risks under control. 2. Build trust through transparency and fairness. Trust is the fuel that keeps AI adoption moving. The framework promotes clear communication, fairness, and accountability so people can understand how and why AI makes its decisions. 3. Use the 4 core functions. Think of these as the 4 gears of responsible AI. Govern sets the rules and accountability. Map understands where risks exist. Measure tests and monitors performance. Manage takes action and continuously improves. When all 4 work together, the AI machine runs smoothly and safely. 4. Trustworthiness, the core of every AI project. When designing or using AI, always keep trustworthiness front and center. Think of it as the moral compass that guides every decision throughout the AI life cycle. 5. Apply to real-world sectors. The AI RMF isn't just theory. It's used in healthcare, finance, transport, and beyond. It adapts to each context, helping teams manage the unique risks of their industry. 6. Promote continuous learning and improvement. AI doesn't stop evolving, and neither should risk management. The framework encourages organizations to monitor, learn, and adapt, ensuring AI remains trustworthy over time. Thank you for joining the session on the NIST AI RMF. I hope it has helped you understand how to build AI systems that are trustworthy, transparent, and responsible. Keep exploring, keep questioning, and remember, responsible AI starts with informed people like you. See you next time. Goodbye.